Hello guys, welcome back to Analytical. This is a video for analytical geometry and let's get to it. So in analytical geometry, we are going to cover the concept of distance, and here's the formula for the distance we want to talk about. We are going to cover the concept of midpoint, and here's the midpoint that we want to talk about. Let me choose this color to be white. Yeah, so here's the midpoint we want to talk about. We are going to cover the concept of gradient, and here's the formula for gradient. And okay, midpoint, something is missing here. This is supposed to be a semicolon, so also here semicolon right there. Yeah, distance, midpoint, and gradient, that's what we are going to do for this video. So hope you'll enjoy this with me, and let's get straight to it. Starting with distance. When we talk about a distance, like we're just talking about the distance between 2 points. So here we need to always remember the formula. So my way of teaching the distance formula is that you adjust the formula based on what you are working with. So this question says calculate the lengths of line segment AB and CD. So here is AB, here is CD. So I'm going to do AB. If you think you can do it, please pause the video and resume to see the answer, whether you got it the same way as I did. And then after I've done B, I'll also do DC. Find the length of DC by pausing the video and see if you can find the answers. So let's get to it. The distance of AB. Let me choose a very lighter pen. Thickness. Let's choose this. Yes, much better. So the distance of AB is x at A minus x at B. We square that, plus y at A minus y at B. We also square that. And all this is under a square root. And then you write down your coordinates. Coordinates of A, according to this diagram, my coordinates for A, it's 2 and 3. Then my coordinates for B, according to the diagram, it's 5 and 7. You see that? Now for me to calculate the distance, now my distance is going to be equals to x at A. I'm substituting now from this equation. Now I'm substituting x at A is 2 minus x at B, which is 5. We square that. Y at A, that is 3, minus y at B, which is 7. We square that. And all this, remember, it's under a square root. Do not forget the square root. Therefore, my distance is going to be equals to 2 minus 5. That is any value that you can get. So, but in fact, you know what I would advise you to do? Whenever you get to this point, you wrote the formula, you did the substitution. The next thing that I want you to do is to just get a calculator, put everything on a calculator, and avoid making mistakes. So let me do that with you. So when I put all the values on a calculator, this is how much I get. Now let's remove this calculator. So here I can simply say my answer is 5. But then because I was talking about distance, I'm supposed to attach a quantity that's used to measure distance. So because I don't have centimeters or meters or anything, I'll just say units. That's how it goes. You see that? Now please pause the video and see if you can find the distance of DC. I hope you paused the video. Let's show you the answer. So the distance of CD is equals to, remember you always have to write the formula first, and it's better for you to create the formula. X at C minus x at D, we square it, plus y at C minus y at D. We also squared it. Now if here you started with C, here you also have to start with C. You can't say x at C minus x at D and then here you say y at D minus y at C. No, you have to follow the same pattern when you write this equation. So that's how it goes. Then you write down your coordinates. My coordinates for C, according to this diagram here, it is -5 and 6. My coordinates for D, according to this diagram, it's -2 and 1. right? Then now we go to substitution. My distance for CD is going to be equals to my x at C is how much? -5 minus my x at D is how much? -2, which makes this positive. See why it's positive? I hope you do. I have to put this phone on silent. Then my y at C is how much? It's 6 minus my y at D, which is how much? 1. We square that. And remember what we said here, put everything on a calculator. In these situations, you might feel like the calculator is wasting your time and you want to test your brain power. But on a test, you don't have time for those things. On an exam, you do not really have time for those things. So this is how much I got on my calculator. That distance CD is equals to √34. But then when you are answering from a question paper, it's on the cover page, on the instruction, it will usually say, convert all your answers to 2 decimal places. So which means here, the answer that I got here, first I have to write it in this way to be in a root form, just in case the examiner might want to mark it this way. But following the instructions that are on the cover page, I have to end up this answer in 2 decimal places. So here I have 5,83 units. That's my distance. Unless maybe this specific question will tell you, leave your answer as a third, then leave it as a third. But then if they don't, then follow the instructions that you saw on the cover. Hope we're good. Now, when we say calculating distance on analytical geometry, does it mean you'll always find questions that are this easy? Just find the distance of AB. No, not really. Some questions will look like this one here. This is how you should expect your questions to come on the exam. They won't just say, nah, find the distance of AD and AD, it's so obvious. They have to put that concept in a diagram that is mixed with another concept. I hope it makes sense. So look at this diagram here. It says, in the diagram, you have 2 triangles that have been drawn. You see this diagram. So they're saying now show that triangle ABC is an isosceles triangle. Here is ABC, this triangle here. That's the first question, right? We have coordinated A, we have coordinated B, and coordinated C. But then remember what we've been saying all the time. When they ask you one question in one way, find a way to rephrase the question. In a way, try to rephrase the question in a way that you think this is what they actually wanted from you. So they're saying, yeah, show us that this is an isosceles, but basically they're just saying to you, show us that this triangle has 2 sides that are equal. So it can be this side and this side, or it can be this side and one of the sides. So we just have to check. That's all we have to do. So I'll start with the distance BC, and I'll go to the distance AC. So let me say the distance of BC is equals to x at B minus x at C, I squared it, plus y at B minus y at C, I squared it. Let me cut that here. And I also want to check the distance of AC. Maybe these are the sides that are equal in an isosceles triangle. So x at A minus x at C, I squared it, plus y at A minus y at C, I also squared it. This should be under a square root, and this should also be under a square root. So remember, for isosceles triangle, I only have to prove that 2 sides have the same distance. That's what they actually wanted me to prove here, right? Rephrasing the question, remember that. So the next step here, I almost made a mistake, is to write down your coordinates. So my coordinates for B, I have -2 and 3, right? And then my coordinates for C, I have -5 and 7. You always need to write your coordinates. I know there are other educators who would say, nah, it's okay, you don't have to. But I know there are situations whereby you'll actually need to write the coordinates. And how you identify those situations, that's another story, another complicated story. So for your safety, just write the coordinates. Okay. So substitution, my x at b is how much? It's -2, minus my x at c is how much? -5. So which makes this a +5. You saw what happened there, right? And here my y at b is 3 minus my y at c, which is 7, and I also square that. So here distance of BC, it's going to be equals to 5 units. Now, how did I know that? Did I just calculate that in my head? No ways. I used the calculator here to save time and to be more precise. So please try to do that too. So here, almost made that mistake again here. I have to write the coordinates first. So coordinates of A, I have 2 and 6. Coordinates of C, I have -5 and 7. Now I can do my substitution. My x at A is 2 minus my x here, which is makes this a positive. Do we see that? And then I have my y at A, which is 6, minus my y here, which is 7. We square that. And this is equals to my distance of AC, 5√2. Now, are those two values the same? No. So it means the two sides that I chose in this triangle are not the ones that are equal for this one to become an isosceles. So I need to find another side, which is AB. You see that? So at first I compared this side with this side, and then I found out that they are not equal, right? One side is another value, the other side is another value. So in this triangle now, I have to find AB and see how much is AB. It should be equal to one of the two sides. So distance of AB is equals to, write the formula in terms of what you have, the coordinates you have. Is it wrong for you to say x2 minus x1 and y2 minus y1? No, it's not wrong. Just that this way it simplifies everything. You don't have to identify which coordinate is coordinate 1, which other coordinate is coordinate 2. No. You just write the formula based on the coordinates you have. So then here we write down the coordinates. A is 2 and 6. Then coordinates for B is -2 and 3. Then substitution. My x at A is how much? It's 2 minus my x at B, which is how much? 4. My x at B, which is how much? -2. So which makes this a positive. Then my y here, my y is how much? My y at A is 6 minus my y at B, which is 3. And we also square that. Therefore, my distance for AB is equals to, this is equals to 5 units. So what did we just do there? We proved that this side is equals to that side, therefore making this triangle to be an isosceles triangle. So now I just have to make my conclusion. So we don't need this side because it's not equals to any side. Now I get to the part of answering the question. So just by calculating 2 steps, it doesn't mean I've solved the question. I still have to answer the question. So my answer to the question, I'm going to say, therefore, triangle ABC is an isosceles triangle because, remember the symbols, BC is equals to AB. See how easy is that? There's a mark for the conclusion. There's a mark for you calculating these things. There's a mark here. See that? Easy 5 marks for you, grade 10s. Now, let's get on to the next question. The next question says, the perimeter of triangle ABD. You see that? So, in the triangle ABD, let me highlight things for you. In the triangle ABD, we already have the value of AB. AB is how much? It's 5 units. Right? So now we need to find how much is this side, and we need to know how much is this side. So remember, we said when they ask you about distance, they're not just blatantly going to ask you what is the distance of AD. Now they're going to give you a question that will demand you to calculate the distance. That's how they ask you the distance, right? So now, how do we get to that? The only thing that I need to calculate now is the distance of AD and the distance of BD for me to find the perimeter of this other triangle. So now that I've erased everything, remember what we said. We said, choose a pen here. We said that the distance of AB, we've already calculated AB, and we said AB is 5 units. We did that in the previous question. So now what do we have to find? We have to find AD and we have to find BD. See that? So let's do that here. Distance of AD is equals to x at A minus x at D squared plus y at A minus y at D squared, and all this is under a square root, right? Then we write the coordinates. Coordinates of A, we have 2 and 6. Coordinates of D, we have 5 and 0. Then we substitute. X at A is how much? It's 2 minus x at D is how much? It's 5. We square that. Plus y at A is how much? It's 6 minus y at D, which is 0. We square that. Therefore, my distance for AD will be equals to 3 root 5 units. Did I just calculate that in my head? No, I used the calculator. So because remember the instructions at the cover page, they usually say leave your answer to 2 decimal places. I'm going to write my final answer now in the format that has 2 decimal places. Units. Right? I wrote the 2 solutions. Based on what the examiner needs, he will get everything from me. The next part, we still need to find the distance. Oh, here, let me write the distance here. The distance here is 6,71 units, right? And then the next part, I need to find the distance of BD. So the distance of BD is equals to x. Oh, sorry, we need a bracket there. I need to get x at B minus x at D squared plus y at B minus y at D squared. All this under a square root. That's the distance formula. So next part is to write the coordinates. Coordinates of B, I have -2 and 3. Coordinates of D, I have 5 and 0. Then substitution. Oops, almost made a mistake. Substitution, I'll put a square root there. X at B is -2 minus x at D, which is 5. We square that, plus y at B, that is 3, and y at that is 0. We square that. And this is under a square root. Therefore, the distance of BD is equals to the root of 58. Always use your calculator, guys. Therefore, to respect that principle that will say leave your answers as 2 decimal places, I'm going to say this is 7,62 units. Now, we haven't answered the question. The question said it wants us to determine the perimeter, in which that means we should take all the sides of a triangle, add them together just to get the perimeter, right? So let's do that. The perimeter in this case is equals to 5 units plus 6,71 plus 7,62. Therefore, the perimeter is equals to 19,33 units. See how easy is that? That's all. So when they ask you a distance, they won't say what is the distance of da da da. No, they're just going to ask you a question that needs you to calculate the distance. All right. So moving on. So for midpoint, here's how it goes. You need to remember the formula all the time, right? I'll be good there. Now the formula says, let me get the pen. let me wait for it to load. Okay, here we go. The formula for midpoint now, it says coordinates of a midpoint, I'll have x at a plus x at b all over 2 and y at a plus y at b all over 2. Right. And then now I need to write down my coordinates here. Coordinates for a, I have 2 and 1. Coordinates for b, I have 8 and 3. Right. So now I do my substitution. To get the coordinates of my midpoint, I'm just going to substitute here. What is my x at a? It's 2 plus what is my x at b? That is 8 all over 2. What is my y at a? That is 1. And what is my y at b? That is 3 all over 2. Now coordinates of my midpoint, it's going to be this, it's going to be 10 over 2, that is 5. This is going to be 4 over 2, that is 2. So my coordinates now for the midpoint are going to be these ones. What do we mean by midpoint? We are talking, like, I think the word itself is self-explanatory. We are talking about the halfway point of a line, right? The midpoint, the middle point of a line, right? So are they going to ask you questions for midpoint in this manner? No, we all know that they won't. The manner in which they'll ask you these questions, it's as follows. Now look at this diagram here. This is a midpoint question, and how they ask you here, they just give you a scenario. In that scenario, you're supposed to be able to determine that what they want here, it's midpoint. So let's check here. It says the following sketch shows a parallelogram. That's a very key point. For them just saying that this is a parallelogram, that's a very key word there. Let me underline that. Parallelogram, right? So they are saying there is a parallelogram A, B, C, D. I'm sure you can all see that. And then with P, the point where diagonals intersect. Right. The first question now says, determine the coordinates of P. Now, what do we know about a parallelogram? We know that a parallelogram, one of its properties, of course, you don't have to recite all its properties just to answer this one question. No. You have to be mindful of the following, that a parallelogram has its diagonals bisecting each other. Now, what does that mean? That means this part here will be equals to this part, right? Like AP will be equals to PC. Diagonals are bisecting each other. Therefore, I can simply say my coordinates of P is the midpoint of the line AC according to properties of a parallelogram, right? So let me put that in writing first. I'm going to say AP is equals to PC. Now, what is my reason for that? Diagonals of a palm. You see that? Now I can now conclude that now P is the midpoint. Now, how do I find coordinates of P? According to the formula of midpoint, I'm supposed to say x at A plus x at C all over 2. Remember how you create the formula. You create the formula based on the coordinates you have. You don't just write anything, right? Okay, sorry, I have to put my phone on silent. I'll do that later on. And then I write my coordinates. Coordinates of A, I have -1 and 3. Coordinates of C, I have 2 and 1. You see that? Then now I do my substitution. my x at A is -1 plus my x at C, it's 2 all over 2 semicolon. My y at A is 3, my y at C is 1 all over 2. Now what does that give me? This means my coordinates for P, -1 plus 2, that is 1. Then 1 over 2 is just a half. It remains a half. My x value is a half. And then what is my y value? Judging from this, my y value is 2. We all see that. So now these are the coordinates of P. See how beautiful is that? They just asked me for the midpoint. They just didn't say it out loud that, you know what, Manala, give us the midpoint. You see that? And now it says determine the coordinates of D. Now that's one of the most interesting questions. D, you actually have to use the midpoint, but you have to see now that in this case you're not really using the midpoint like that. So I was just turning off my blue light filter. I was just checking whether it's still off. Now how do they want that? So I think my blue light filter is still on. This is too dark. Yes. Oops. Disable this thing for now. Disable for an hour. Yes, I hope it works. Yes, that blue light filter I know is going to make this video too dark. Yes, what I was saying, this is a midpoint question. I have coordinate B, I have coordinate P, I have coordinate D. So one thing I know is that the distance BP is equal to the distance PD. Why is this line equals to that line? Diagonals of a palm. Diagonals of a palm. A palm, yes. So now, which means P is the midpoint, right? And what do I know from my coordinates? The equation will say coordinates of P, I can find them by saying x at B plus x at D all over 2. They should give me supposed to say this here. Why are you guys not telling me that I'm making a mistake? So here we are. I know that this is the formula for calculating the coordinates of the midpoint P. But then the thing is I already have the coordinates of the midpoint, right? And so, which means I can use the coordinates of the midpoint now to find the coordinates of the end point. Does that make sense? So the end point of this line, which is D, I can use coordinates of the starting point and the midpoint to find the end point. So now, what do I know? I know that for me to find coordinates of P, which is the midpoint in this case, coordinates, the x coordinate of my midpoint will be equals to, right, this part here is equals to me taking the x component of B plus the x component of D, make all of this over 2, right? So which means now in this case, if I make my substitutions, let me write my coordinates. My coordinate at B is -4 and -1. My coordinate at, let me use a different color here. My coordinate at P is, I already have that, 1 over 2 and 2. And then lastly, my coordinate at D is unknown. So my coordinates for D, they are unknown, right? So I'm looking for those things now. So I'm going to use this part here for me to get the coordinates of D. See that? Now let's make a substitution. So substitution, what is my x at P? My x at P is 1 over 2. That is equals to, what is my x at B? My x at B is -4. Plus, what is my x at D? D doesn't have a coordinate, so I'll just say x at D. See that? All over 2, right? And then now I solve for, this is what I'm looking for, x at D, my x coordinate for D. So to do that, I'm going to multiply both sides by 2. So I'll multiply this by 2 so I can get rid of this denominator. What I do on the right, I also do on the left. So this will cancel with this, and this will cancel with this. So I'll be left with, in this case, 1 on the left side. It's equals to negative 4 plus x at d, right? And I'll have to transpose this to another side. It will become positive. So I have 1 plus 4 is equals to x at d. Therefore, my x coordinate at d is equals to 5. We see that. So I found my x coordinate at d. Now I have to find my y coordinate at d, right? Let's do that. So my y component of d, I know that my y of the midpoint is equals to my y of the starting point plus my y of the end point all over 2, right? I'm just taking the midpoint formula here and now cutting it into half, right? And then so I already wrote the coordinates here. Now I go to substitution. What is my y at p? Let me go there. My y at p is 2. This is equals to, what is my y at b? My y at b is negative 1. So I say negative 1 plus, what is my y at d? I don't have y at d, which is actually what I'm looking for. And here's a 2 here. And then how do I remove the 2 there? I'll just multiply this side by 2. And what I do on the left, I also do on the right. So I'll also multiply what I do on the right, I also do on the left. So I'll also multiply the left side by 2, right? So which means this side now I'll have 4 is equals to negative 1 plus y at d. Now I'll transpose this to the other side. So I'll have 4 plus 1 is equals to y at d. Therefore, my y at d is equals to how much? 5. So which means now I can say, therefore, coordinates of d, I know that x is 5 and y is 5. And here are your marks there. Easy as that. Hope you all said there with midpoint. So you can be asked to find the midpoint. Obviously, they won't say it so obviously as we all expect them to. They'll give you a scenario whereby you'll have to understand that in this case, the only way I can solve this is to use midpoint. Or they can give you the starting point and the midpoint, and you'll have to find the end point. Or they can give you the midpoint and the end point, and you'll have to find the starting point. I hope that makes sense. So they'll just strategically find a way to ask a question from you, to you, that will demand you to use the midpoint. They just won't put it as plain as you would expect it, right? So to the next part now. This part here, we have to talk about gradient. Now, gradient, let's start with its basic concept. When we talk about gradient, we're talking about a slope. How steep or how gentle is a slope, right? So in this case, let's say I have a line like this one here. This line, its slope compared to this line, we would say this is more steep and this is more gentle, right? Basically, that's what the gradient is about, how steep or how gentle a line is, right? So now, obviously, there's more to it. So the best way to start with it is to use small m. Now, in midpoint, whenever the symbol for midpoint, it's a capital M. Sorry, let me use this. The symbol for midpoint, it's a capital M. But then the symbol for gradient, it's a small m. I hope you see the distinction there. So now, the formula for gradient, it says my y at b minus my y at a all over my x at b minus my x at a. Now, remember, the formula is subject to change based on how your coordinates are, right? You can say, there are other people who would say the formula for gradient is y2 minus y1 all over x2 minus x1. You are also correct. Remember, the formula is subject to change. You just have to show that you are taking the change between 2 points, basically, right? So now, since this is the formula for gradient, there are more things to gradient now. It's not just the formula, right? But then let's start with that basic. Let's say a question will say, find the gradient between two coordinates A, and then A, it has a coordinate of 3 and 4, and B, which has a coordinate of 6 and 2. This way. Let's say the question says that, right? So first things first, what you're going to do, they're saying find the gradient of a line, or find the gradient between two coordinates, between coordinate A and B. So in this case, for you to just find the gradient, you're just going to use the formula. You're going to say y at B minus y at A all over x at B minus x at A, right? And then after that, you write down the coordinates for me. You write coordinate A, you write coordinate B. Coordinate A is negative 3 and 4. Coordinate A is negative 3 and 4. Coordinate B is 6 and negative 2, right? And then after that, you do your substitution. Your substitution, you're going to say y at B, that is negative 2, minus y at A, which is 4. So here we go, right? And then you have x at B, which is 6, minus x at A, which is negative 3, so which makes this a positive, and then this way, right? Therefore, this is equals to how much? This is equals to negative 6 over this is equals to 9. Therefore, making our gradient to be negative, what is this in the simplest form? This is 2 over 3. So our gradient is negative 2 over 3. It's easy as that, right? And then that's if they ask you a question like this one. But there is more to gradient. There is more to gradient. So what else do we have? There is gradient for parallel lines. There is gradient for collinear points. There is gradient for perpendicular lines. So let's get through the concepts. So let's start with parallel lines. Now I want to put, okay, it's fine. Let's do that. So when you talk about parallel lines, let's say we have a line here and we have a line there. Let's call this line AB. Let's call this line CD. The concept here says, if AB is parallel to CD, therefore, the gradient of AB will be equals to the gradient of CD. Why? Because AB is parallel to CD. That's how it is. As easy as that, right? That's how we do things. And then there is a for collinear points. You can have collinear points, you have collinear lines. Let's say that. What does this mean? In the same line. That's what it means. So if I have a line here, and I have a point here, I have a point here, and I have a point here. So let's call this point A, B, and C. We can say point A, B, and C are collinear. Why? Because they are in the same line. That's what collinear means, right? They're in the same line. Or we can say AB and BC are collinear. Why? Because they are in the same line. Does that make sense? So now what do we know about collinear points? Collinear points, now they mean the line that is formed AB. I can say the gradient of AB is equals to the gradient of BC, which is equals to the gradient of AC. The gradient of this short line is equals to the gradient of this short line, and that is equals to the gradient of the whole line. Does that make sense? So as long as we have points resting in the same line, whatever short distance line they form is equal, its gradient is equals to the gradient of the bigger line. Hope that makes sense. So the gradient here, if it's 2, the gradient here will be 2, and the gradient of the whole line will also be 2, right? So the slope of the line, how inclined or how gentle or how steep is that line, it's the same throughout this whole line. That's what we mean. So if points are collinear, then their gradients are the same. The last part now, perpendicular lines. Perpendicular lines. That's probably a wrong spelling for perpendicular, but it's okay. So let's say we have this line here. So this is A, this is B, and this is C, and this is D. And you have a symbol that says here, these lines are perpendicular. So we can say now, the gradient of AC multiplied by the gradient of BD must give us -1. Why? Because AC is perpendicular to BD. Now let me leave that to you to sink in a little bit. That's a nice cup of tea. We are saying here AC is perpendicular to BD. Therefore, if I take the gradient of this line, let's highlight that a bit. We are saying now, if I take the gradient of this line here, its gradient, and I multiply it with the gradient of this line, the product of that must give me -1 at all times. You see those concepts? So that's what it is. Those are all the concepts of gradients for analytical geometry that you need to know for this grade. So let's get to the questions. Obviously, they have to ask you questions, right? So how would they ask you questions? We all know how they will ask you these questions. They won't come as plain as saying, give us the gradient of this. Nah, things do not work like that in maths. So here, it says in the diagram ABCD, you have a rhombus. Now that's a bold statement. Remember that all the time. We have a rhombus, which means we must apply all properties of a rhombus here in this figure that we are given. They're saying F is a point where diagonals intersect. So here's the point F, right? And it already has a coordinate. But what do we know about a rhombus? A rhombus, we know that the distance here is equal to the distance here, which is equal to the distance here, which is equal to the distance here. Let me choose a different color here so it becomes more visible. I was saying the distance here is the same as the distance there, same as the distance there, same as the distance there, right? Those are properties of a rhombus. What more can I say? Will I probably need this? Nah, I probably won't, but even if I do, I'll always remember that. So I don't think I need to highlight that, right? So what else do I know? I know that this line here, this diagonal, is equal to that diagonal because F is the midpoint. I also know that this part of the diagonal DF is equals to FB, right? And I also know that AF is equals to FC, right? And then what else do I know? I know that diagonals of a rhombus, they meet at a 90-degree angle. So every angle around point F is 90 degrees, right? So now let's get to answering questions. The first question here, it says, determine the value of Q. Now that is interesting because here you have to find out the question that they actually wanted to ask you, right? So if you get a question like this on a test, you should see what's possible. What can lead you to getting that coordinate for Q? I mean for D, coordinate Q for D, right? So what do we know? So far in this line DF, the only information I have, it's the coordinate F and half of the coordinate D, right? I don't have the other coordinate. That's all I have. I don't have the distance of this line. I don't have the gradient of this line. I don't even have the last coordinate here, which will make this the midpoint and help me find other things. So basically for the line DF, I don't have enough information to find coordinates of Q. So what do I need? I need to at least have a distance of the line DF, or I need to at least have the gradient of the line DF. I need just one extra information for me to answer that question. But then can I find it now? No, not really. Can I use something else to find it? Yes. What can I find? I can find the gradient of DF by knowing the gradient of FC, right? Let's build that answer now. Let's build that answer and see how we go with it. I know that the gradient of, no, let's study it this way. Let's study this. I want to write this answer step by step so that you get it. I know that DF, like, I want to put this in the simplest way you can get it. Like, my point is not just to get to the answer, it's to help you know how to get to the answer. I know that dB is perpendicular to AC. What is that? These are properties of a rhombus. So diagonals of a rhombus, we know that they meet at 90 degrees angles, right? This diagonal is perpendicular to that diagonal. That's a property of a rhombus. There's no arguing with that. Therefore, my argument here, based on this information we had here about the concept of perpendicular lines in a gradient of perpendicular lines, I meant to say, I can safely say the gradient of dB multiplied by the gradient of AC is equals to -1. Why? Because dB is perpendicular to AC, and I already mentioned that here in this step there, right? So now, do I have gradient of AC? No, but I can find gradient of AC, and after I find it, then I'll use this equation now to find the gradient of dB, right? So now let me find the gradient of AC. Gradient of AC is equals to y at A minus y at C all over x at A minus x at C, right? Let me write the coordinates. Coordinates of A, I have AC. Did I say AC? So the gradient of AC, let's get to this point. We are not really wrong here. We are just half right. Let's say that. So I know that the gradient of AC is equals to the gradient of FC. Why? Collinear lines. Remember what we spoke about when we spoke about collinear lines. I know that AC has the same gradient as FC because this AC and FC, they are on the same line, so they are collinear. We good. So which means here, if I have the gradient of FC, then I have the gradient of AC, right? So now how do I find the gradient of FC? I can use this coordinates F and C, right? So gradient of FC is equals to y at F minus y at C all over x at F minus x at C. Remember not to swap things around. Then coordinates for F, coordinates for C. Coordinates for F, I have 2 and -1. Coordinates for C, I have 3 and -3. Then I go to my substitutions. Let me cut this here. I go to my substitutions now. For me to find that gradient, I can easily substitute y at F. It's how much? -1. So I have -1 minus y at C. It's how much? -3. So this makes this a positive. Then now I have a 3. Then x at F is how much? It's 2 minus x at C. It's how much? It's 3. Therefore, my gradient here is that -1 plus 3, that is 2. 2 minus 3, that is -1. Therefore, my gradient there is -2, right? And that is the gradient of what? That is the gradient of FC. And then we said the gradient of FC is equal to the gradient of AC, right? So now I can go back to this equation that says gradient of dB multiplied by, now that I have this, let me substitute this. Gradient of AC, it's how much? We said gradient of AC is equal to gradient of FC. And the gradient of FC, I just found it here to be -2. So which means here I'll put -2. This is equals to what? -1. Right? Now I just solve for the gradient of dB. So gradient of dB is equals to, how do I remove the 2 to the other side? I remove it by division. So which means here, I'll simply say this whole thing divided by 2, and this side will also have to be divided by 2. Therefore, gradient of dB is going to be equals to how much? Sorry guys. Gradient of dB will be equals to 1 over 2. Not negative 1 over 2 per se. Let me provide space here. We said here, making mistakes, it's still early in the morning. So negative 2, how do I remove negative 2? I divide by negative 2. So negative 2 will be cancelled out by negative 2. Yes, now it's proper. Then we can say my gradient for dB will be equals to, this is how much? Positive 1 over 2. Now that's the gradient of dB. Right. And what do I know? I know that dF and dB are on the same line. What do we call those things? Collinear. Right. So if dF and dB are collinear, then it means their gradients are the same, right? So let me put that down. I know that the gradient of dB is equals to the gradient of dF. Gradient of dF, which is equals to 1. Why? Collinear lines. These are collinear lines, all right? So now I have the gradient of dF. You see how beautiful is that? Now it gets me to the part that I wanted. Now I have the gradient of this line. I have one extra detail. All this work was for me just to get one extra detail about dF that will help me find dF, right? So now I can say the gradient of dF is equals to y at d minus y at f all over x at d minus x at f, right? Then I write my coordinates of d, coordinates of f. What do I have at d? Negative 4 and q. What do I have at f? 2 and negative 1. Then I do my substitution. What is gradient of df? Because I already have this, I just substitute. That is 1 over 2 is equals to, what is y at d? Y at d is q minus what is y at f? Negative 1. So it will become plus 1 here. What is x at d? X at d is negative 4 minus what is x at f? That is 2. Right. Let me provide space here on the left side so I can continue answering this question. Now to answer that, I'll have 1 over 2 is equals to q plus 1 all over negative 6, right? And then how do I remove negative 6 in this case? I'll have to multiply every part by negative 6. Right? I'll multiply this by numerator negative 6, which means I'll also have to multiply this side by numerator negative 6, right? So now negative 6 will cancel negative 6. I no longer have that denominator there. And then here I'll end up with, let's put back the color, negative 6 over 2 is equals to q plus 1. That is how much? That is equals to negative 3 is equals to q plus 1. Then I transpose, which becomes negative 3 minus 1 is equals to q. And therefore, my q is equals to negative 4. Easy as that. See how beautiful is that? Easy as that. So now let me write my q here because I feel like I might need it. So coordinates for d, I have negative 4 and negative 4. See that? Now let's get to the next question. It says calculate the area of CFD. CFD. Do you see that? Now let me clear the space. So what do we know about CFD? So far about CFD, we know that CFD is a triangle. What type of a triangle it is? It's a right angle triangle. Why? Because these angles that are formed in a rhombus, they are all 90 degrees. So I only need to find the distance of DF and the distance of FC, make one part the base, one part the height, and then I find the area of that. So what do they want here? What do they want me to use? Distance, of course. So I need to find distance of DF and distance of FC. So distance of DF is equals to x at D minus x at F, we square that, plus y at D minus y at F, we square that. and all this is under a square root. We said I also need to find what? Distance of FC. So distance of FC is equals to x at f minus x at c, we squared it, plus y at f minus y at c, we squared it. Right? Now, substitution. Before substitution, what do? You write down the coordinates. Coordinates for d is -4 and -4. Coordinates for f is coordinates for f are 2 and -1. Then coordinates for f, we said it's 2 and -1. Coordinates for c are 3 and -3. Right there. Now let's move on. Now, how do you find the distance? We're going to say the distance of df is equals to x at d. What is x at d? That is -4 minus what is x at f? That is 2 squared, plus y at d is -4 minus y at f is what? -1, which makes this a positive. Therefore, the distance for df is equals to this thing. Just put the whole thing on a calculator to get an answer. So here basically I would get 3√5 units. Remember, it's distance, it needs to have that units, or I can say this is equals to 7,1 units. Right? Remember, the question paper will say leave your answer in 2 decimal places. And then distance of FC, now I'll have x at f, which is 2, minus x at c, which is 3, we squared it, plus y at f, which is -1, minus a -3, which makes this a positive, we squared it. And then I have my distance for FC being equals to √5. And √5 is the same as, let me say units, and √5 is the same as 2,24 units. See that? Beautiful. And then now we need to get to the part of finding the area. So now, area of a triangle is equals to half base height, right? My base in this case is FC, and my height in this case is df from this triangle here, right, from the triangle CFD. So now my substitution here is going to be half what is my base, which is FC 2.24, and what is my height, df 6,71. Therefore my area will be equals to 7,52 square units. Remember, this is how we write area. Area will always come to you in square units. All right, so that's how easy things are. And then now to the last question. I don't think I'll answer the last question because it's long. It's going to take me a long period of time, but I'm going to give you an idea. I'm going to give you an idea on how you can answer that question. What I will need you to do to answer this question is to use the following formula. The area of a rhombus, it says you multiply the diagonals and divide that by 2. So if you can find the length AC multiplied with the length BD and divided by 2, then you found the area of the rhombus, right? Right? So how do you find the length AC? We know that AC is equals to 2 times the distance FC. Do you see that? Do you see why AC is equals to twice the distance of FC? Because FC in this case, let's choose a different color. Oops. FC here is FC, it's this part. And then we said diagonals of a rhombus, they bisect, which means FC is equals to AF. Now if AC is cut into half by this midpoint, which is F, it means twice the distance FC will be the whole length of AC, right? Same thing applies here. The distance BD will be equals to twice the distance of DF. So which means if you can use the distance formula to find DF and multiply that by 2, then you'll get this whole diagonal, which is dB. And then you substitute onto this formula and get your answer for area. See how fair is that? Now on to the next question. This is the last one. Now, do I need to do this one for you? No, I think you can do this one by yourself too. It says H is a coordinate with 4 and 0. E is the coordinate with -1 and 2. It says A is the coordinate of -3 and 7. R is the coordinate of 2 and 5. And these are vertices of the quadrilateral HEAR, right? They never told you what quadrilateral this is. And then they want you now to prove to us that this is a palm. This is going to take so much time. I don't think I'll do this one, but I will show you how. I will guide you to how you can prove that that is a parallelogram, right? So far, by this point in this video, I have full confidence that my guidance to you getting to prove that this is a quadrilateral, this is a parallelogram, is enough, right? So let's do that. So what do I expect from you? When they say prove something that is a parallelogram, you need to prove some of the properties of a parallelogram, any properties, right? So in this case, you want to use a property that will lead you to the next answer, basically. The next part, they need you to prove that this is a rhombus. So for the first part, question A, how do you prove that something is a parallelogram? We know one property of a parallelogram. It says opposite sides are parallel. Right? Two pairs of opposite sides are parallel. So which means if I can find the gradient of AR and prove that the gradient of AR is equals to the gradient of EH, then also find the gradient of AE and prove that is equals to the gradient of, let me do this. I feel like I'll end up doing this question because I so much love doing things that are about maths. I'm even lazy to be lazy about it, right? So here, what I want to say, you look for the gradient of AR and prove that is equals to the gradient of EH, right? Which means you'll do what? You'll say y at A minus y at R all over x at A minus x at R. This should be equals to y at E minus y at H all over x at E minus x at H. And then you write coordinates of A and then coordinates of R here, and then you substitute them onto the equation. The final answer you get should be equals to the coordinates of E, you write them here, coordinates of H, you write them here, then you substitute them here, and then you prove that now this side must be equals to that side once you are done with it, right? And then the next part, you prove now that AE, the gradient of AE is equals to the gradient of RH. And how do you do that? You say y at A minus y at E all over x at A minus x at E. This is equals to y at R minus y at H all over x at R minus x at H. And then you write coordinates of A, coordinates of E. Then you substitute them into the equation, and the answer you get should be equals to here you write coordinates of R and coordinates of H, you substitute them into this part, and then the answer you get must be, the left side must be equals to the right side. And then you make a conclusion and say, therefore this gradient, you write the statement again, therefore gradient of AR is equals to the gradient of EH, and gradient of AE is equals to gradient of RH. Therefore, HEAR is a palm because two pairs of opposite sides are parallel. Easy. You'll be done with question A just like that, right? And then to question B. Now, please make sure you do this one, guys. Please make sure you get it right. This question is right. I know it's right. I've done it before in my class. So please make sure you do it. The next part would say for question B. Question B will say, prove that quadrilateral HEAR is a rhombus. Now, how do you prove that something is a rhombus? Right. There must be one specific thing that will make this a rhombus, right? So basically you can say, like, what is one thing about a rhombus? What is one thing about a rhombus? A rhombus, we know that all sides must be equal. That's one thing about a rhombus that distinguishes it from other things. Do not say opposite sides are parallel, because that can also be a parallelogram. You get what I'm saying? That can also be a rectangle. So you have to use one property that is specially unique to a rhombus, right? Now, that property is to say all sides are equal. You can never confuse that with a parallelogram. You can never confuse that with a rectangle, right? So to do that, obviously you have to find the distance of AR using the equation and then you find the distance of AE using the equation then you find the distance of EH using the equation and then you find the distance of RH using the equation You see how many steps are here? I won't finish this video now if I do that. After you find all the values that you get here, they should be the same. They should be, unless you did some wrong substitutions. And then after you've proven all that, then you can say, therefore, HEAR is a rhombus because all sides are equal. Easiest, that's a property of a rhombus that distinguishes it from a rectangle and a parallelogram, right? So easy as that. This would be worth a lot of marks if you ever get a question like this on an exam, which I doubt, but it will be worth a lot of marks because there are a lot of calculations there to do. So we've reached the end of the video, guys. I hope you enjoyed. Please hit the like and subscribe button if you haven't yet, and I appreciate you for getting this far. See you on the next one.